Good morning, and welcome to the launch of the Emerging Technologies Institute's flagship study, Hypersonic Supply Chains, Securing the Path to the Future. I'm Dr. Arun Serafin, the newly coronated Executive Director of the Emerging Technologies Institute here at the National Defense Industrial Association. I'm in that position now because of the great work of Dr. Mark Lewis, who's with us today, the inaugural director of the Emerging Technologies Institute. I just want to take a moment to thank Mark for a lifetime of friendship, a lifetime of mentorship, and all the great work he did to help stand up ETI and be the driving force behind the event that you're at here today. In addition to Mark, we're joined by my boss, CEO of NDIA, former Deputy Secretary Norquist, and Congressman Lamborn has joined us here today. So thank you all for coming. We're also joined by extremely distinguished audience, both in person and virtual, and a great panel that we're going to hear from later. And I think this is going to be a very constructive event for us. ETI was established by NDIA's board and leadership to leverage its unique assets, namely our industry, government, and academic members, and their unique technical and programmatic and, most importantly, mission understanding, and convening authority that we have here at NDIA in a nonpartisan and neutral fashion to strengthen our voice, to strengthen defense industry's voice in the important conversation that we're having on how the nation can best take advantage of emerging technologies in support of our national defense and deterrence missions. It's well understood that new technologies and the scientific advancements that underpin emerging sectors will drive and shape the battlefields of the future and, in fact, the whole national security enterprise. This is more true now than ever as our top global competitor, China, seeks to reduce or even eliminate the technological advantages that we'd always taken for granted. The board's vision for a heightened focus on emerging technologies is made much more imperative by the accelerating pace of technological change, by the proliferation of sources of new technologies, and by the increasing ease of proliferation of those same technologies across the globe. So ETI's activities then span the range of emerging technology areas, including microelectronics, software, AI, robotics, and hypersonics, to name a few. We're also looking at the policy environment that shapes how industry and government can develop and deploy those new systems of the future, including looking at acquisition policy, workforce issues, and budgets. Today's report release is an example of what we try to do to bring NDIA member companies together with academia and government to provide the nonpartisan, expert-informed, and practical analysis and discussions into Washington's conversation on defense modernization. Our team has a drumbeat of these kinds of activities ranging from our webinars and educational sessions to our biweekly podcasts to our major emerging technologies conference that we're going to hold in August in Washington, D.C. I encourage you all to look at our website and our YouTube site and see what else we're up to. When ETI was created under Mark's leadership, we set out to assess the state of supply chains for some of our most vital emerging technology areas, while also providing recommendations for their development, health, and resilience. Hypersonics is the first of many such reports. We believe the insights and recommendations found in these reports can substantially enhance the security and reliability of critical supply chains, and we're extremely excited to share our findings with all of you today. Some quick administrative remarks before we begin. First, you can access the report at ndia.org/hypersonics, and that link is on your screens now. For your awareness, this event is being recorded. You're welcome to record it for your reporting purposes. During the panel, we encourage our online participants to please submit questions via the Q&A box. Finally, for those who are in person, please see the front desk at the end of the event if you need a parking pass to exit the parking garage. Very important information. With that, now I'd like to introduce my boss, NDIA's President and CEO, the Honorable David Norquist.
Good afternoon, and thank you all for being here, both in person and online. This is, as you mentioned, Arun's inaugural event as ETI's executive director, having served ably as its deputy director for over a year. Arun, great note to start on. I look forward to the rest of the music that you will compose. ETI's activities are a core part of NDIA's robust set of programs, publications, and conferences, where we try to focus and elevate the government-industry dialogue on how together we can support the operators today and win the technology race of the future. Hypersonic development is right at the heart of great power competition. Technological advancement is absolutely imperative to deter and decisively win conflicts. And ETI is playing a fundamental role in solidifying this advantage. However, in order to succeed, hypersonic weapons must be supported by a secure and resilient supply chain, from mining and processing critical raw materials to manufacturing key components. Each tier of the hypersonic supply chain is essential to maintaining our competitive advantage. We succeed on this, we take it seriously, and future generations are better placed to prevail in any crisis. NDIA has supported our warfighters for over 100 years, and we are committed to supporting America's national security for the next 100 years. So I'm honored to welcome our panel, our distinguished guests, and to have those join us in the discussion from online. Welcome to NDIA. It is now my honor to introduce our keynote speaker. Congressman Doug Lamborn represents Colorado's 5th Congressional District and currently serves on the House Armed Services Committee as the chairman of the Strategic Forces Subcommittee and a member of the Tactical Air and Land Forces Subcommittee. Congressman Lamborn also serves as co-chair and co-founder of the House Hypersonic Caucus. And today we'll discuss the importance of hypersonics to U.S. national security. Ladies and gentlemen, please help me welcome Congressman Lamborn.
Thank you for that kind introduction, David. Good afternoon, everyone. I'm Congressman Doug Lamborn from Colorado Springs. I'm chairman of the House Armed Services Strategic Forces Subcommittee and co-chair of the Bipartisan Hypersonics Caucus. It is my pleasure to speak to you on the release date of the Hypersonics Supply Chain Report. It was authored by Rebecca Wastenberg and others who are joining us here today. Through the National Defense Industrial Association's Emerging Technologies Institute, critical issues like hypersonics are being addressed, and this is so vital. I was asked to provide you with a congressional perspective on our nation's hypersonic capabilities. It was my hope that we would be able to also speak about where we stand with this fiscal year 2024 National Defense Authorization Act while I was at it, but so much for that plan. Here's what I'll say for today. I will talk about providing for the common defense of our nation because this is the first and foremost constitutional duty of the United States Congress. I do have every confidence that the House Republican leadership will balance the NDAA among all the other priorities that they are managing. Debt ceiling increases and things like that I'm sure you've heard about. And I expect that we will resume the NDAA process in a timely manner. I do believe that American development of hypersonic capabilities is non-negotiable. This is a technology that was born in America, but is being perfected by China and Russia. This is all because we made a bad decision 20 years ago to abandon what we had first started. Now we are witnessing the consequences from the sidelines as we struggle to get back into the game. China's technological advances in hypersonic capabilities are the pacing challenge. Their test of a hypersonic glide vehicle with fractional orbital bombardment capabilities clearly signaled to the world that Beijing intended to take first place in the hypersonics arena. Russia, on the other hand, has developed, fielded, and used hypersonics in operations during Vladimir Putin's unjust invasion of Ukraine. Some of Russia's hypersonic systems are known to be nuclear armed. China and Russia's advancements have proven two different operational concepts. There are both strategic and tactical uses of hypersonic capabilities. This gets to the heart of the questions that frequently arise on Capitol Hill when discussing how we should prioritize hypersonics. What is the plan? What are the strategic imperatives we are trying to achieve? Are these weapons for deterrence or for standard operations, or both? Some people would prefer to have these answers to these very important long-term questions before embarking on a full-on program of record for hypersonic capabilities, but we have wasted too much time already. The fact is that hypersonic capabilities would provide our military with a crucial tool that will be necessary to deter or fight in a future conflict. All the advanced technology solutions that are being developed now, quantum, artificial intelligence, and directed energy, to name a few, will make the pace of a future war much faster than it is currently. These technologies will reduce decision time for senior leaders while requiring reliable capabilities for rapid response or action. The time frame gets shorter and shorter. The ability to use hypersonic capabilities will buy back some time in the decision cycle while providing additional options for reaching deep strike targets that currently can only be reliably reached with nuclear assets. Most importantly, they will enhance deterrence by causing an adversary to second guess whether the United States has the capability to credibly respond or overcome any nefarious actions that they might be considering. This NDIA report makes clear that without a strong demand signal from the government, industry will not be able to achieve the momentum it needs to develop the talented workforce or create the production lines that will be necessary to support the hypersonics supply chain. I come to you today to clearly convey this message. The demand signal from Congress is here, and it's only going to get stronger. The NDAA, when it finally does get passed, will make that clear. I will share my goal for the near-term acceleration of our hypersonic efforts. We must achieve qualitative parity with China and Russia. I am not arguing for a quantitative goal that some would call an arms race. Rather, I envision a near-term mix of capabilities that leverages advanced technology and refined production processes to achieve qualitative parity with our competitors. This is necessary not just to enhance deterrence. It will also add urgency to our ongoing research and development to drive these processes toward fielding and production at an accelerated rate. For our first generation of hypersonic capabilities, I envision a suite of capabilities across the military services that complement, enhance, and augment our existing and planned weapon systems. For the future of warfare, I see a generational leap ahead in technology in which hypersonics, artificial intelligence, quantum computing, directed energy, and other currently nascent technologies are commonplace. To achieve qualitative parity with China and Russia as quickly as possible, there are 4 areas in which I am concentrating my time and efforts. My first priority is to accelerate our development of hypersonic capabilities. We must expand testing and make it cheaper and more accessible. Testing is fundamentally a logjam currently that is impeding forward progress in many defense technologies, but specifically hypersonics. Retired General Hyten frequently said that we should not be afraid of failure. And I believe it's true that we learn just as much from failures as we do from successes, if not more. This is what ultimately accelerates progress. This is a cultural shift that I encourage as often as I can, and that I hope the department and industry are beginning to internalize. Unfortunately, the current testing regime proves that this mentality has not yet been fully adopted. Deconflicting test range schedules, among other programs, is challenging enough, but it is made virtually impossible when considering the supporting elements that must all come together in order to monitor a test and collect relevant data. Multi-million-dollar string of pearls tracking vessels have to be laid out in the ocean every time a hypersonics test occurs. This is enough to make some want to throw up our hands and walk away from the endeavor entirely. So while I am frustrated, as many of you are, by the immense challenges posed by testing, I am encouraged by recent progress. Over the past 2 years, Congress has consistently added funding for expanded testing capabilities. This includes an initiative I led in last year's NDAA specifically geared to get after this issue, the National Hypersonics Initiative. I am encouraged by progress the Department is making on the Multi-Service Advanced Capability Hypersonics Testbed, or MACH-TB, which seeks to perform early tests on hypersonic capabilities. This includes the Army's long-range hypersonic weapon that is set to field later this year and will be America's first operational hypersonic capability. I believe that there is still a lot of room for improvement in testing. I am hopeful that the department can continue to build on existing progress in the MACH-TB program and related initiatives. I hope DoD will continue to work with all stakeholders on solutions to address this challenge in small and large ways. We will see more progress on this in the fiscal year 2024 NDAA. Second, we must continue to invest in various capability options at this stage in our development. I am not concerned that each of the military services and even parts of the Office of the Secretary are working on their own similar but different hypersonic capabilities. I think it's a good thing. I'm concerned that we may give up on a concept too early and hone in on one solution before fully understanding the operations, the options, and implications of all of them. There are inherent connections in the programs at this stage between these various approaches. The Army's LRHW this year will inform and help the Navy's plan to field conventional prompt strike aboard DDG-1000s in 2025, which will inform the Navy's follow-on plan to field conventional prompt strike on Virginia submarines in 2028. By exploring two technologies with Aero and HAC-M, the Air Force is charting the way in developing options for land, air, and sea-based concepts of hypersonic capabilities. There's discussion now over Aero specifically, which I would like to see continue in some form so that we can leverage the technology investments we have made. Even if this program moves in another direction, we can harvest the gains. Third, we must reduce barriers to collaboration to foster accelerated development. The United States should do more to work with allies and partners to co-develop hypersonic technology and leverage each other's expertise to achieve faster breakthroughs to our mutual benefit. There is ample opportunity to expand these partnerships with others in our network of international allies and partners. There are plentiful opportunities for the department to work with commercial companies right here on our own soil. However, as many of you know, it is not always easy to work with the Department of Defense. David, you know a little bit about that. To address this, one of my top priorities for this Congress has been to demand that the department seriously address its overclassification tendencies. My emphasis in this area has mainly focused on the space domain, which I think is the most rampant example. If taken seriously by the department, reducing overclassification would have positive implications for hypersonics developments as well. The department's inclination to mislabel or overclassify information is more than just an annoyance to certain members of Congress who don't have ready access to classified systems. It fundamentally inhibits progress on technology when even trusted industry partners are challenged to fully understand the scope and intent of the department. And this is not to mention other industry, international, or commercial partners for whom classification restrictions are an insurmountable barrier to entry. Furthermore, it fundamentally undermines robust public discussion on the efficient use of taxpayer dollars and understanding the strategic and policy intent of our military. Even within Congress, it's difficult to fully convey the extent of the threat to colleagues who don't always get the threat briefings that we on the Armed Services Committee do get. Addressing this issue and reclassifying information when appropriate is critical to fostering forward progress. Finally and fourth, we must encourage hypersonic offensive and defensive capability development to occur in tandem and to leverage the work of each other. The HBTSS satellites that are going up this year will be able to detect, track, engage, and provide the fire control necessary to destroy hypersonic threats. This capability will ultimately be carried out by the Glide Phase Interceptor. As these capabilities are developed and fielded, they should seek to partner with offensive research, development, and testing to inform their target set and even assist to relieving some of the tracking burdens that exist in our current testing infrastructure. This is another area in which industry can lead the way in developing the next generation of hypersonic capabilities. This can be done as we work on the targets and technology to inform defensive requirements that could be leveraged to develop offensive requirements. So I am honored to have the opportunity to lead these important efforts in Congress as chairman of the Strategic Forces and co-chair of the Hypersonics Caucus. With these four efforts, expanding testing, investing in multiple technology solutions, addressing overclassification, and expanding defensive capability developments, I believe we can get ourselves onto a path towards qualitative parity with China and Russia in hypersonics. Thank you all for being here today. You want to learn about the specific challenges facing the hypersonic supply chain that NDIA has identified. So this is an important discussion. I appreciate what NDIA and the ETI are doing to accomplish this. It is essential that we overcome these challenges to achieve success in our hypersonics efforts. It's a pleasure to speak with you all, and I hope you enjoy the rest of your discussion this afternoon. Thank you so much.
Thank you, Congressman Lamborn, for those great remarks. It's leadership like that, with that detailed understanding of the technical challenges, the programmatic challenges, the budgetary challenges, that make me feel like Congress can be an active player in the development of these capabilities. And hearing about the NDAA delays makes me even more happy to be here with all of you than where I normally would have been this time of year. I'd like now to discuss a little bit more about the ETI's hypersonics report and why we conducted the supply chain study before I turn it over to Rebecca, who led the study, to give an overview of the key findings. I'm sure that many of us are familiar with the challenges our supply chains have faced in recent years. The COVID-19 pandemic and subsequent economic challenges exposed the vulnerability and weaknesses of many parts of global supply chains. And the war in Ukraine has drawn even more attention to supply vulnerabilities, particularly in the defense and manufacturing sectors. As we stand today, it is fair to wonder, with respect to our defense supply chains, how healthy are we truly if a global conflict breaks out? Within the defense sector, vulnerable supply chains are not uncommon. The U.S. government recognized this issue years ago, and the last two presidential administrations have taken steps to try to address it through executive orders and reports. Congress has also recognized the need for action. Early in 2021, the House Armed Services Committee launched a bipartisan defense supply chain task force and subsequently published a report outlining key findings. Think tanks and not-for-profit research organizations have also undertaken initiatives to address these broader supply vulnerabilities. These efforts, both inside the government and outside the government, are indicative of the issue's importance. However, areas that have received considerably less attention outside government are those in the nascent supply chains that will support advanced capabilities and emerging technologies, as outlined in the 2018 and 2022 National Defense Strategies. These technologies are often those that are intended to give the United States its unrivaled advantage on the battlefields of the future. These are the supply chains that ETI specifically focuses on with this series of reports. Given the scale of DoD's hypersonic ambitions, current supply chains are unable to meet the anticipated future production needs and demands. To rectify critical hypersonic supply chain vulnerabilities, a holistic and coordinated approach between government, industry, and academia is essential. This integration will facilitate the cost-effective and reliable production of operational hypersonics systems and their sustainment into the future. Although the current state of the supply chain is in question, if action is taken now, hopefully working off of this report, the DoD's hypersonics aspirations are within reach. Next, we'll hear from Rebecca Wassenberg, the lead author of this report, to give us an overview of the key findings and its recommendations.
Good afternoon, everyone. As Arun said, my name is Rebecca Wastenberg, and I'm the chair of the Supply Chain Study and the lead author for the Hypersonics Supply Chain Report. Before I begin, I would like to thank a few people in particular. First, I would like to thank the University of Maryland Supply Chain Management Center team for their partnership in this study. A special thank you to Jeff, Suresh, Megan, and CH for all of their hard work in helping to lay the foundation for our study. Next, I would like to thank all of our working group participants, some of whom are here in the audience today. Your insights and perspectives were invaluable in this effort. I would also like to thank our distinguished members of our peer review committee and our external reviewers. Finally, I would like to thank most of all my fellow authors of the report, Wilson Miles, Jordan Chase, and Samantha Bew, and the entire ETI and NDIA teams, both past and present. As Arun said, the vulnerability of U.S. supply chains has become more apparent in recent years. As such, ETI set out to assess the state of defense emerging technology supply chains and provide actionable policy recommendations for their development, health, and resilience. Before I discuss the key findings and recommendations from the report itself, I want to discuss our methodology a bit. ETI sits in a unique position here at NDIA. What makes us different than other think tanks in Washington, D.C. is the NDIA member base, many of whom are here today. Among the 65,000 individual members and more than 1,800 corporate members, we have many who provide the key links in the hypersonic supply chains. Recognizing this, we set up our report methodology to leverage this unique insight and expertise. First, we established what I mentioned before, our partnership with an academic member of NDIA, the University of Maryland. Working with UMD Supply Chain Management Center, a team of professors and graduate students utilized open source information to map the hypersonic supply chains. Given the opaque nature of these supply chains, this was no easy task, but the results of their research provided a foundation for us to build off of. Next, we launched 8 working groups consisting of 22 participants from industry, government, and academia, including many NDIA members. Each of these participants brought a wealth of hypersonics expertise and experience to bear on 4 aspects of the hypersonic supply chains. First was critical raw materials and goods. Second is manufacturing base and workforce. Third is supply chain security and vulnerabilities. And fourth is international partnerships and allied nearshoring. The insights from these working groups were compiled with UMD's research, information gathered via one-on-one interviews with experts, and internal research conducted by the ETI team. Prior to publication, the report was submitted to our distinguished peer review committee and a group of external reviewers with deep expertise in hypersonics. These groups provided invaluable feedback on the product that you have before you today. I'd now like to share some of the key findings and recommendations from the report. Like Arun said, overall, we assess that the current hypersonic supply chains, including the manufacturing base, supply of critical materials, testing infrastructure, and workforce, are incapable of supporting deployment of hypersonic weapons at scale. Why is this? Unfortunately, the primary reason for this assessment is the lack of consistent demand signal from the U.S. government for hypersonics, as Mr. Lambourne referenced earlier. Over the years, DoD has wavered in its commitment to fielding hypersonic systems at scale. This issue was raised time and again throughout our working groups. Over time, the government demand signal has varied greatly, leading to a small hypersonics manufacturing base with limited suppliers, suited only for manufacturing limited numbers of hypersonic systems with long lead times. From the industry perspective, companies must know that they will receive a return on investment. Industry, from what we heard, is eager to invest in hypersonics technology, but the business case must exist for companies to invest in the necessary infrastructure and personnel. As I mentioned before, our report examines 4 aspects of the hypersonic supply chains. The first is critical raw materials and goods. Hypersonic weapons require substantial quantities of critical raw materials and goods. And here, the supply chains face a plethora of vulnerabilities. While the report goes into much more detail on a number of these, I'll touch on just a few today. First, high-temperature materials are crucial for hypersonic systems, including applications like heat shields, thermal protection systems, rocket engine components, leading edges, and the like. Within high-temperature materials, a number of different materials and metals are needed. One of the most important materials used in coatings for higher-speed hypersonic systems is carbon-carbon. However, according to one working group participant, there are only 3 suppliers for carbon-carbon composites used in hypersonic vehicle coatings. Another vulnerability is in rare earth elements. Obviously, rare earth elements have numerous applications outside of hypersonics, but Chinese dominance in both the mining and processing of rare earths introduces significant risk into hypersonic supply chains. One material that has seen some positive movement in recent years is ammonium perchlorate, or AP. AP is a principal raw material used in solid rocket propellants. Until recently, American Pacific was the only DoD-approved domestic supplier of AP. However, Northrop Grumman has recently stood up AP production, bringing the number of suppliers to 2. While only time will tell if 2 suppliers is sufficient, a second entrant into the market could reduce the risks associated with only 1 supplier and could potentially reduce costs due to some competition. Another vulnerability discussed in the report is the supply of neon. Much work has been done recently on semiconductor supply chains, so our report only touches on the topic briefly here. But hypersonics and many other supply chains face a significant vulnerability due to global reliance on Ukraine for neon. Neon is a necessary component used in the lasers during the lithography process for semiconductors. Ukraine is responsible for approximately 50% of the global supply of neon, and more than 90% of neon for U.S. semiconductors is sourced from 2 Ukrainian companies. Given the Russian invasion of Ukraine last year, this has put the supply of neon in jeopardy. Given these significant vulnerabilities in the critical raw materials and goods needed for hypersonics, we provided several recommendations throughout the report. First, Congress and DoD should reinforce the national defense stockpile of strategic minerals. The stockpile has diminished over the years, especially following the end of the Cold War. This potentially increases U.S. dependence on China in times of unexpected increased demand. With funds for maintaining the stockpile also nearly depleted, Congress and DoD should work together to reinforce and maintain the national defense stockpile. Second, DoD should provide a clear demand signal to private industry to increase investment in additional carbon fiber suppliers. Finally, the U.S. government should set the regulatory environment to permit and incentivize more domestic rare earth element mining and processing to lessen our reliance on China. Some recent efforts have been made in some of these areas, but much more work remains. Moving up the hypersonic supply chain to manufacturing base and workforce, we found that both were insufficient and faced many issues. Overall, the hypersonics manufacturing base faces limited suppliers. For example, there are only two U.S. suppliers of rocket motors used in missile propulsion systems. According to working group participants, limited supplier issues also exist with hypersonic structural components like TZM bolts and protective items such as thermal blankets that shield the vehicle from excessive heat. Because the commercial market is almost non-existent for these materials, the industrial base remains small and the market fragile due to inconsistent demand from the Department of Defense. At the same time, due to the lack of demand for large quantities of hypersonic weapons and a low supply of components, lead times have grown exponentially. Although testing infrastructure is not traditionally considered as a component of supply chains, it plays a crucial role, as Mr. Lambourne spoke of earlier, in moving hypersonic systems from the early developmental phase to a fully fielded system. Therefore, it was deemed within the purview of this study and a topic that was raised multiple times throughout our working groups. While testing infrastructure could be and has been the subject of an entire study in and of itself, we touched on a few key issues throughout our report. First, hypersonic systems must compete for test time slots with current high-priority programs, such as missile defense and nuclear deterrence. The age of existing testing infrastructure is also a significant issue. Most testing facilities were built decades ago and lack modernized data acquisition tools. The report covers additional details, but overall, existing testing infrastructure for hypersonics is insufficient and must be addressed. When it comes to the hypersonics workforce, the report discusses several challenges. First, the hypersonics workforce as a subset of the aerospace industry and thus faces similar challenges of that whole industry and others in the post-COVID era. Things like seeing higher employee turnover, a shortage of talent, etc., also applies for hypersonics. According to working group participants, the current hypersonic specific talent is also unbalanced and misaligned to current needs. For instance, there's a plethora of early and mid-career aerothermal expertise, but a dearth of expertise in other needed areas such as hypersonic controls, system design, and high-temperature materials. These challenges in manufacturing base and workforce are all things that government, industry, and academia will need to work together to address. In the report, we outline a number of recommendations with actionable steps that can be taken both in the short term and the long term to address these issues. The most important immediate step that the Department of Defense can take to strengthen hypersonic supply chains is to send a consistent demand signal to industry by treating certain hypersonic programs as traditional programs of record and utilizing multi-year contracts to send an extended demand signal. At the same time, additional testing infrastructure needs to be funded jointly by government and industry. The defense industry also must ensure that it has the traditional and additive manufacturing capabilities needed to produce hypersonic systems at scale. The Research and Engineering Office in the Office of the Undersecretary of Defense should continue to pursue an air-breathing hypersonic vehicle system as a key element of its development plan. On the workforce side, academia should be leveraged via the University Consortium for Applied Hypersonics to educate mid-level hypersonic talent, and DoD should leverage existing scholarships and fellowships to strengthen early career hypersonics talent. The third aspect of hypersonic supply chains that we addressed in the report is security and vulnerabilities. Unfortunately, hypersonic-specific examples can be challenging to find in open source, but some significant conclusions can be drawn from an analysis of recent examples in related industries. Overall, these supply chains, like other emerging technology supply chains, face a range of threats related to cybersecurity, counterintelligence, and intellectual property theft. The working group participants also raised a number of key issues as well. Cybersecurity threats to hypersonic supply chains begin at the very lowest tier, mining and production of critical raw materials. The report discusses a number of cyber attacks that have occurred in recent years against various mining and processing companies working in areas like rare earth elements and other metals crucial to hypersonic systems. The working group participants also raised a significant cybersecurity challenge at the lower tiers of the supply chain. Smaller, low-tier suppliers often lack the necessary resources for robust cybersecurity measures. The business case can be sometimes almost non-existent for these small companies to invest in the necessary infrastructure for cybersecurity measures. Recent reports also indicate that China has recruited several former scientists from the Los Alamos National Lab to work on their hypersonics programs. At the same time, Chinese transfer of expertise for hypersonic programs reaches down to the semiconductor level, with specific examples outlined in the report. Given these vulnerabilities, industry, government, and academia need to take steps now to secure hypersonic supply chains for the future. Some of these steps that they could take now include DoD should address this major cybersecurity risks at the low to mid-tier level by perhaps creating a bug bounty program for small government contractors working on hypersonics. At the same time, the FBI should work with industry and academic leadership at all tiers of the supply chain to increase awareness of counterintelligence threats. The final aspect of hypersonic supply chains addressed in our report is international partnerships and allied nearshoring. Overall, the United States has several great partnerships in place on various aspects of hypersonics. We assess that these partnerships, however, need to be strengthened to better secure hypersonic supply chains in various ways. First, given the challenge of testing infrastructure that I discussed earlier, the United States should look to close partners and allies to help address this issue. The U.S. already has great partnerships with Australia and Norway in this regard, but these could be expanded. At the same time, the U.S. could look to Canada and Australia and their deposits of rare earth elements and other critical raw materials to help diversify and lessen reliance on China. Again, this is an area that is starting to receive some attention, but much more work remains to secure hypersonic supply chains for the future. Overall, our report lays out a number of challenges that the current hypersonic supply chains face. However, we also provide recommended solutions. As I mentioned earlier, the most important step that the U.S. Department of Defense can take today to strengthen hypersonic supply chains is to provide a consistent demand signal to industry. Action must be taken today. Each of these challenges will take time to address, but are critical for securing the path to the future. Thank you for attending today, and with that, I'll turn it back to Arun.
Thanks, Rebecca. Now I know what you guys have been doing all this time and all those meetings you've been having. It's great. I'd like to invite now our panelists to please join us up here at the front. While the panelists are taking their seats, it's my honor to introduce our moderator for today's panel, the Wall Street Journal's National Security and Foreign Policy editor, Sharon Weinberger. Thanks for joining us, Sharon.
Great, thank you. I always joke that journalists only know as much as the last people that we interviewed. So it's a great pleasure here to have 4 experts in hypersonics, which I am not. It's certainly a subject I've written on and off over the past 20 years. So I want to introduce Marty Hunt of Dynetics, who's the Vice President of Hypersonics and Advanced Manufacturing. Dr. Mark Lewis, who I've known for quite a while, who is now the CEO of the Purdue Applied Research Institute. Sorry, these change of job titles. Dr. Chuck Ormsby of the Air Force Research Laboratory, who's the Chief of Manufacturing and Industrial Technologies, and Jason Fisher of Northrop Grumman, the Market Area Lead for the High Speed Tactical Boost. So I actually wanted to start off with talking about something very current, which is Ukraine. You know, we've seen when it comes to supply chains that there have been challenges for the U.S. defense industrial base, even keeping up with the demand and trying to increase production of missiles that are currently deployed. How much has that helped highlight the problems with hypersonics? And also, how will the prioritization work? So when we talk about supply chains and what's needed, will hypersonics in some effect be in competition with those missile programs that are both being used now by Ukraine, and also as the Pentagon pivots towards great power competition and tries to build up its arsenal for a conflict against a potential peer competitor? And I'll open that up. Oh, I'm sorry, we're starting with remarks. We'll come back to that.
All right. Okay. All right. Thank you. Yeah, some of what I'm going to say will be echoing comments that Rebecca made, which were really dead on with the reality of what we're dealing with this day and time. So when I take a step back and I look panoramically across the hypersonic supply chain, what I see are different pieces that have very complex structures to them that are tied to other supply chains outside of hypersonics. So effectively what happens is when the demand changes and additional demand is added outside of hypersonics, it starts drawing on the resources within the hypersonic supply chain. It affects the raw materials, as was mentioned, and that is illustrated based on lead times, the volatility of lead times of materials and finished products that we see, as well as cost, which is a key factor. Because we don't have the leverage of high volumes within the hypersonic supply chain itself. But also a critical aspect of this is related to the workforce. So when these other supply chains are flexing and increasing demand, it draws the high-tech workforce away from hypersonics, which has a negative effect. It can slow down the efforts and the programs that we have in process. So with that, the report that came out was an excellent review of identifying a lot of key facets of problems or challenges within the supply chain, and the conclusion of that there aren't programs of record with high volumes, also that there's not a strong demand signal through the supply chain, establishes an inherent problem with the supply chain resilience for hypersonics. If we take and we drop down one level from the high level that we've been talking about and we look at the impacts to the companies, if you bifurcate the types of companies that are involved in the supply chain, you have a lot of smaller companies that are niche technology companies. If they do not have a solid demand, what will happen is they start getting pushed into that valley of death for companies. Because they don't have the throughput and the funding. For the larger companies, there's a balance between the future demand and are there going to be programs of record, and comparing those comparing, do you invest in that versus other programs that are competing for those same funds. And from a manufacturing standpoint, you have what I've seen is a lot of companies going out and investing in infrastructure to support hypersonics. That includes training the workforce, which with hypersonics being a higher tech area, it takes a longer time to ramp up the workforce. And if the demand is not there, what happens with the facilities and the equipment that the companies and the workforce that the companies have set for supporting the ramp up on hypersonics, they get drawn easily to other competing programs and requirements. And then we find ourselves in this loop of having to ramp up and retrain the staff. So I keep, pointing to workforce. So what I've seen is within the workforce, people that are coming out of school, going through school, also entering the workforce, they need an anchor point. They need to be able to see a career trajectory that holds them in the hypersonics arena. The way that they see that is steady funding and also programs of record in the future. If they don't see that, then it's a very short burst of resources that get funneled to hypersonics. Once they're trained up, they get robbed basically for other supply chains. So if you look in the other areas that were mentioned, Rebecca covered several areas, that same situation really transcends through the raw material supply chain. There is a significant amount of training that goes into refining materials and such, and building that knowledge base. I just want to make sure that that there's a clear view that when we're looking at the supply chain, that really the underpinning of all of it is our core workforce, and that we're focused on that and establishing funding to support that workforce. So with that, I'll pause and pass the board over to Mr. Lewis.
Thank you. So if I could, I actually want to tell you the anecdotes of my two favorite days in the Pentagon in the job I had before I came to NDIA, where I am no longer. The best day that I had was when we in the R&E office presented what became known as the Hypersonic Acceleration Plan, which is essentially a plan to get from hypersonics in numbers, onesies, twosies, handful of weapons, which I've always said will not scare anyone, to a plan to deliver hundreds and ultimately thousands of these weapons. And it was driven very much by by analyses that we had done in the building, which basically showed several key points. And many of you have heard me make these points before. The first is when we do wargaming, we have blue team versus red team. When red team has hypersonic capabilities and blue team doesn't, red team usually wins. When both blue team and red team have hypersonic capabilities, and it's a matter of depth of magazine. So being able to present a plan forward to the then Secretary of Defense Esper and Deputy Secretary Norquist and the service secretaries and the acquisition executives, and have them saying, yes, this is the right thing to do, was about as satisfying as it could be. That was the first best day. The second best day that I had was actually a briefing a little bit before that, where I was at the front of the room and I was briefing Secretary Esper and Deputy Secretary Norquist, who left us, so I can tell this story without him. And I got to a slide. First, the best part of the briefing is I get to a slide where I'm talking about the various types of technologies, air breathing, boost glide, and Secretary Norquist stops me and says, wait, what do you mean by air breathing? That was going to be my next slide. He was jumping the gun. And before I can answer, Secretary Esper, the Secretary of Defense, turns to the Deputy Secretary of Defense and says, well, he means like scramjets and that sort of thing. So I had a briefing partner in the Secretary, and I knew that we had incredible support from the front office. But later on in that briefing, Secretary Esper asked me, which is one of perhaps my single favorite question, which is not why hypersonics, but why not hypersonics? Why isn't every weapon going to be hypersonic? And I told him it was a great question, and I gave him the answer. There are many reasons why not hypersonics, but one of them is cost. And my very dear friend and colleague, Al Schaefer, would often foot stomp, if you're going to deliver this capability, you have to deliver it at low cost. Because if you can't do that, then you're not going to be delivering in the large numbers that we've said we need, as per the previous discussion about the Hypersonic Acceleration Plan. So cost, deliverability, availability, absolutely essential if we're going to bring this technology to bear. And of course, it's more complicated than just cost per weapon. It's cost per effect, and we can go through all those arguments. But at the end of the day, that's what a lot of this report is about. How do we make sure that we have this supply chain so that we are not delivering onesies, twosies, an experiment here, a flight demonstration there, but instead able to deliver at the numbers and at the low costs that are necessary to make this a capability. And as Marty said, a big part of that is workforce. Another huge part of this is test and evaluation capability. Being able to test early, often on the ground, in the air, get things flying, break them, figure out why they broke, fly them again. And that's all encapsulated in this. So let me stop there, hand the floor over to Jason, but I know you'll have some follow-on questions.
Right. Thank you. Very good points from both gentlemen. Things I can add from the industry perspective. Certainly, the consistent demand signal is key. If you're going to get the benefit of corporate investment, they need to see a demand signal for their products so they know that there's a rate of return in their investment. So with Northrop Grumman, actually in the last few years, we did see that demand signal coming in the hypersonics market. All the air-breathing systems, they need a booster to propel it up to take over a Mach. So increased demand for boosters, increased production demand for scramjets, ramjet systems. So Northrop Grumman has actually invested pretty heavily in new buildings and facilities, specifically at our Elkton, Maryland location. This July, we'll be opening our first production building for the production of scramjets and ramjets. It'll all be done at Elkton. We also build the rocket motors also at Elkton, and we have a new large final assembly building put in place and now operational just for the hypersonic boosters as well. So we have geared up. We are currently migrating or developing the HACM cruise missile, and that'll be the first product that actually goes through our facility. And as we do that, the building is up. It comes down to getting the equipment in place and the workforce. So right now it's a great building. Machines are starting to show up, but we're also in the process of trying to build that workforce, recruit them, train them. Certainly we're pulling from experienced folks we already have within our facility, but then those folks have to be backfilled for the conventional products that they were already building, which kind of also leads me to your question on the Ukraine impact. So yes, in addition to hypersonic weapons, we also need to backfill all of our conventional weapons that have been, sent over and used up. So that material supply base does not exist currently, not the way it used to be when those older systems were first built and deployed. So we are getting a lot of interest now in, programs that would typically you deliver a small amount of maintenance products per year. All of a sudden now the services want 10x times what they've been getting. So again, in addition to ramping up for the hypersonic mission, you still need to ramp up your facilities and supply chains for just backfilling the conventional products as well. So it's probably a good problem to have for industry, but it is certainly a challenging one as well, and trying to get everything built and out the door to the warfighter across the board is our goal.
So I'm Chuck Ormsby, and to make sure I don't forget, let me start with Rebecca. Thank you, to your team, to your working groups. Very, very nice product, very well done, and I think it's going to be critically important for our nation. And I as an airman, as a retired Air Force officer, now a civil servant, I really appreciate what you and what industry are doing to take care of our airmen specifically, because I still bleed Air Force blue. Nice remarks, Dr. Lewis. It's wonderful to see you and Al Schaefer again. I remember the days together in the Pentagon, I've got to say, you say you sold the vision of delivering thousands of these weapons, right? And you said they've got to be affordable, right? And that is what I am doing now, running the Air Force Manufacturing Technology Program. Our objective relative to hypersonic weapons is to go from these onesie-twosie weapons that we are able to produce today to a 10 to 100x increase in numbers at a 10x reduction in the price of those weapons. That's where we're structuring our program. That's where we're investing with our industry partners to try to drive manufacturing processes, automation, to get to a capability that a manufacturing workforce can build with high school diplomas, with some trade school, as opposed to where we are today with a lot of touch labor and PhDs like me doing it all by hand, and it's really more art than it is science in a lot of cases, right? We're putting the science behind now, turning it into something that can be built at rate and at a cost that we can afford. And that's really where I will focus my comments today is what we're doing to enable that and how that's going to bring the capability that our nation needs. So thank you.
Great, thank you. My eagerness to ask questions as always. Actually, I'll start with a question for Mark, although if others want to chime in, that's good as well. The report, which really is a really good read on some of the underlying issues, and has been repeated by some of the panelists, one of the challenges is the demand signal, having that demand signal for the Pentagon. I think the report cites about 10 unclassified hypersonics programs. Presumably there are more that are classified. How does the department establish those programs of record and that demand signal without making choices between that number of programs?
Ooh, well, so of course, I can't, and neither Alan or I can speak for the department any longer, which is great because now I get to speak freely. So I think there are a couple of elements to it. One is the recognition that hypersonics is not one thing. It is a very, very broad range capabilities, from relatively expensive medium-range strike to less expensive air-breathing cruise missiles, and we have to keep that in mind. The department needs to be able to run parallel lines of effort and compete different concepts. So I'll give you the example. It was mentioned by the congressman that in the Air Force you've got the Arrow program, the boost glider, and the air breather. Both of those are important. They each have their strengths and weaknesses, and in combination, they give you an incredible capability. We need to avoid the instinct to do a down select for one and the other. Some of it comes down to cost. But my one of my bosses in the Pentagon, the first time I was there, Mike Wynn, used to say, if it's important enough, we'll find the money. And I think that needs to be the mindset going forward.
I'll echo a little bit on the Air Force in particular. I think the congressman's remarks that we need to not down select too early, that we need to have parallel programs, we need to develop the technology, we're spot on. We have had some issues in the Air Force that are causing us to question where we're going. But I will say within the science and technology development portfolio, we are still moving forward just as fast and just as robustly as we ever had on parallel paths, because we do believe we need options. We do believe that we need to develop the technology, the workforce, the industrial base as much as we can for both. And we also believe there's a lot of pervasiveness in a lot of the underlying technologies. So we can still invest and as he said, leverage and reap the benefits of those investments even after the down selects happen. And so that's where we're putting a lot of our investments in pervasive technologies. We have for a long time been working on the carbon aeroshells and getting those to production rates and costs that we would need for a boost glider. We're starting to look at boosters because we see the demand signal coming up there and we see pervasiveness there. A lot of other pervasive technologies across both classes of weapons that we can invest in and keep the options open.
Just to add a little additional insight there from industry. Certainly, getting to a program of record and down select is the end goal for anyone on the winning team, certainly. But what you want to avoid is certainly a down select too early, where maybe you pick the wrong horse after the fact, and you've sunk that investment money in. So open competition, multiple parallel paths, suppliers working towards the same problem. Not only does it burn down the risk of on the DoD for ultimately getting a product that will work. It also strengthens the workforce and the supply base for both of those companies that have that work, that continue to invest and train those folks while they're on that competition phase. So certainly early down selects are probably not the greatest idea. Obviously, there is budget constraints that come with that, we understand, but so, active competition is good for many reasons.
Another element that I'd like to add to this is a badgeless environment. So as we're working these teams, these national teams that may be made up of industry, academia, the government. It's really important to have a badgeless type of work environment so that there's complete transparency for lessons learned, and there's not an apprehension to share things that are being learning as you're going through that growth cycle on a program. And likewise, even when there is a down select, just ensuring that that knowledge base is transferred so that it's consolidated, so the next time we're going through program developments like this, we're leveraging those lessons learned to advance ahead faster than what we normally would.
Thank you. So going back to the Ukraine question, we're seeing quite a backlog in missile production currently. I think foreign military sales to Taiwan have something like a $20 billion backlog, and much of that is missiles. Is there and will there be competition between conventional missile production and hypersonic missiles, and how should that be dealt with? And are you seeing that already to any extent? I'll address that to Mr. Fisher, but I can open to others.
Well, certainly right now, at least the programs I've been involved in at the Elkton site, we're meeting all the demands of the contracts we have. Certainly, we take on work if we need to hire more folks. We do that. We ensure that our contracts are met. The challenge really comes in when you get an RFP for a quantity that is well in excess of what you've been producing, and typically the timeline to get to that quantity is very short, within 1 to 2 years, because the need is immediate. And those are the situations that are really hard for industry to respond to. It does take quite an amount of energy and convincing an effort to get capital funding from your corporate offices to make the business case to invest and facilitize to get this work that you may win, maybe you don't. So there really has to be a strong business case and a strong probability of winning and the program going forward for industry to invest in that capitalization, especially with such a large delta gap from going to those crazy quantities. So that is a challenge, and we are seeing more and more RFPs like that coming in. And they're almost, I wouldn't say impossible problems, nothing's impossible, but it's a very challenging project and effort to try to figure out how to ramp up that product line while also maintaining your existing footprint of products that you already have to deliver, right? You almost need a dedicated part of the plant or dedicated facility just for that new product, and that's standing everything up from the ground zero. So that is a challenge.
So I don't think that this addresses your issue with timing and rapidly building capability unless we are very predictive. But I do want to put in a plug for our partners in OSD in the Defense Production Act Title III program. Aisa Tovar, the deputy there, that directs that program, because that is an opportunity where you're having struggles convincing the upper leadership of industry to invest in scaling up your manufacturing capability, facilitizing and such. The government can invest and help you to do that, right?
Right.
And we have a number of presidential determinations already that open that capability. OSD determines where we will invest the dollars that we have. We have dollars for both Ukraine, as well as there's money set aside for hypersonics in the portfolio. And then once they make a decision on where they want to invest, they actually direct my office to then build the program and manage the program. So there is, for folks that don't know it, a open funding opportunity announcement. If you just Google Defense Production Act Title III open funding opportunity announcement, you can put in a white paper unsolicited and make suggestions on where that money should be invested to help build capability.
Yep, and we actually at Northrop have taken advantage of the Title III, and we have several investments already in place at Elkton. So, yeah, definitely agree. That's a fine avenue to try to help solve that.
But you got to be thinking ahead.
Right. That's my point. The timeline is very long, going up to 2 years or so from white paper to actually money coming in the door to make that investment. So again, surge needs across the country and the manufacturing industries, that's really the challenge. There really is no surge capability for a lot of these older weapon systems, especially if they haven't been in production in serious quantities for some time.
I'll make this an open question to the panel. The report outlines a number of vulnerabilities. Which one or ones concern you the most?
I guess I'll start. So on the solid rocket motor side, even hypersonic or conventional, they use common materials, and a lot of them are extremely long lead to get. And when you're in the defense industry, you're competing with the commercial industries for a lot of these materials, and their need greatly outweighs our small orders. So it is very difficult to try to get priority and to get those materials promptly. So we have several materials in rocket motor construction that are up to over a year of lead time. So again, if you're talking about getting a contract and trying to instantly turn out rounds, there's that upfront startup. It's gonna set you back while you get your long lead materials in place, and sometimes it is a very frustrating situation to be in. It's also very fluid. One situation last year where I bought some material, came in 4 months, tried to go buy some more, and I'm being told that they're not taking orders till 2024. So it's a very dynamic supply chain. So that's mine.
So I was actually, my initial response is intellectual property theft, except the train already left the station, and we've already been robbed blind. So, but that is absolutely key. I mean, one of the secrets to the success of our competitors' programs is that they've been able to rob us blind. Some through legitimate means, open literature, some through not so legitimate means. And going forward, it's clearly something we have to deal with.
What can we do about it?
Well, first, I think there are a number of steps already in place. I think industry has just become much more sensitive about it. We're already seeing those changes. I'll tell you the area that I'm most impressed by, and that is actually in academia. So I'll give you a really good example. One of the things the department set up is a university consortium called the UCA, the University Consortium in Advanced Hypersonics, operated out of the Joint Hypersonic Transition Office. First lead of that effort is actually with us today. Jillian, I'm going to give you a shout out, Jillian Bussing. When that was set up, universities were told if they're going to participate, then they had to abide by certain rules and regulations. There would be review. There would be an analysis of who would be participating in these programs. And the great part about that story is a number of universities stepped up to the plate and said, yes, we're willing to accept these rules, accept these guidelines as the price of admission to the program. Some were not. They were told, thank you very much for your interest in national security, but the overwhelming majority of universities were. And I think that program has been running quite well. And I think it's a model, by the way, of how to do this sort of sensitive work in academia for other technical areas.
In terms of solutions, we've heard mentioned a lot the demand signal. And of course, that is a problem across different programs. What else beyond demand signal? Many of the aspects in the report, like rare earth materials, are a problem for more than just hypersonics. What more can the government and DoD be doing to help this? And I'll make this open to whomever wants to jump in.
Well, I guess I called in all the fires on myself by admitting I'm government, didn't
Yes.
I? Okay. So I think it's a broad approach, honestly. I think the Title III program has a lot of capability there. Part of the presidential determinations does allow for addressing critical chemicals, critical minerals, et cetera, and there are some efforts underway already to increase domestic production capability. So onshoring is very important. Friendshoring where we can't onshore is very important. Honestly, though, I think the demand signal really is our big issue. We have to give a robust demand signal that's going to allow for those investments that industry needs to make, that's going to inspire a workforce to work in this area. I thought the report was spot on that is our biggest issue. It's what I hear consistently every time that I speak at any kind of an event like this from our industry partners when they come in to tell us what their pain points are. We don't have enough of a demand signal to really generate the momentum behind the programs that we need.
Is demand signal enough to address the supply chain issues? Are there things Congress should be doing, or?
Well, I think that Congress is helping to create that demand signal, quite honestly. When I look at my own portfolio of investments, Congress is very robustly, as the congressman said in his remarks, telling me what they want from me, to the tune of $51 million put into my portfolio last year with specific hypersonic investments directed with that budget. And I'm hearing more and more now from staffers, both personal staffers and professional staffers on the committees, of we're considering putting an ad in for next year. This is what we're thinking about doing with it. How does it align with what the Air Force is doing? How will it accelerate what the Air Force is doing? That is something that honestly I am not accustomed to. In the past, a lot of those ads came in and we kind of looked at them and said, I'm not real sure what this is. And then we had to figure it out. Now we're getting the advanced conversations going between Congress, industry partners, and ourselves, and they're really increasing that demand on us. So I think that's good from my perspective.
Sure. If I could jump in too, I actually think we're at an important inflection point because industry was hearing the demand signal from the government and in many cases has already made investments. Jason talked about the investments in Northrop Grumman. Marty's already making investments. I mean, you've got private capital coming in. Stratolaunch, Danny Millman, CTO at Stratolaunch is here. It's private investment in a T&E capability. I think if the government fails to now follow in with that investment, it's going to be devastating not just for hypersonics, but for the industry. Because they've stepped up to the plate. They've said, okay, we've heard what you need. Here you go. We've got this capability. And now it's frankly, it's up to government to say, okay, thank you for that. Thank you for doing that. Thank you for that investment. These are capabilities we need, and we will invest and use them.
Just to add on to that, and I appreciate those comments. We've had a lot of programs over the years, development contract, very aggressive. Get a product that works, like, all right, now build 1,000 of them. But there's no funding really dedicated towards the EMD phase of a contract where you really flesh out all your quality issues, your repeatability issues, your producibility issues. So several of these urgent mid-tier acquisitions, they get right to the end product and they want to go to initial operating capacity. But you need to have the funding there to fund those EMD activities. Otherwise, you're going to end up with a product that is maybe glitchy or doesn't have the reliability or is not affordable because you've locked down the process and the product and you didn't invest in trying to streamline or produce those units at an affordable cost. So that is a challenge that we have seen on several programs in the last few years. What we're doing, though, with the HACM product here is in the design phase, we're bringing in digital tools, producibility type software programs, looking at capacity planning, looking at production throughputs, looking at ways we can design the product in a way that is simpler to build and cheaper long term. So we are actively working on the producibility and the cost reduction initiatives now in the design phase. So it does seem like there is some funding there available to do that with this product. So we definitely appreciate that. I've been on programs where that was not available, and that doesn't always work out well.
In terms of that demand signal in EMD, Mark, what are you looking for? What should one be looking for from the Pentagon in terms of providing that demand signal? What would be the first sign that things are going in a great direction?
So we used to say on the E-ring, budget is policy. It's great to make pronouncements, but you've got to be putting your money where your mouth is, and I think that's what we're really what we're going to be looking for. We're going to see continued investments in HACM. I'm an unabashed fan of HACM, by the way. We're going to see continued investments in that. We're going to see it moving forward. I'd like to see Arrow continue as well. I'd like to see those efforts not not just come to an end. I think we see those sorts of things. Once we get to deployment, that'll be really important. It looks like the Army is still on track to deploy first. I think if they deploy, but not just in small numbers, but continue to deploy in larger numbers, I think that will also be the sign that this area is really being taken seriously.
Let's talk about workforce issues for a second. This can be across the panel. Obviously, demand signal is an issue there, but what are other things affecting that? I mean, you've got people going in at the lower end. What will attract or not attract people to this field?
Certainly, Northrop Grumman, we get a lot of comments that the products that we build are exciting and interesting. So you get a lot of young engineers, hey, they want to be involved in that technology, whether it's space-based or hypersonics, so that does have a big draw. We do a lot of internship programs with colleges, rotates dozens of interns through each season. A lot of them do stick around and become employees, which is good. We are like any other industry, there's there's an aging workforce approaching retirement, and a large quantity or breakdown of the aerospace workforce is or could retire tomorrow if they wanted to. Then you have a lot of new folks, and then there's a gap in the middle, right? I think your report pretty much pointed that out as well. So yeah, I'm certainly seeing that locally. I started there 25 years ago as one of those young guys, and I remember all the old faces of the great beard engineers. They're all gone now, so there's not too many of them left, and the folks that were at my level have now moved up to that spot. So it is, I think it's a constant challenge, not just for Northrop, but all of the aerospace industry.
One of the challenges that I've seen is for students in the universities and such, you have clearance requirements. And just the duration for them to get the clearances so that they're able to be engaged with the work and really understand what's going on. That's a key piece that we need government assistance with, of how to manage through that and navigate that from an industry perspective.
What would government need to do?
Well, I think it hinges back upon the comments made earlier about classifications, making sure everything is classified at the level that it should be, have those gates in there, but if things are not required to be at certain classification levels, then remove that requirement. So that would allow workforce to engage faster, prior to going through that process effectively.
Is that a difficult balance? Because, of course, Mark, you talked about we were sort of robbed of our intellectual property. So how do you balance that desire for managing classification but also preserving what the U.S. has?
So you're exactly right. It's difficult. In many cases, it requires a certain amount of common sense. There were, frankly, certain students from certain nationality in certain nations you don't put on your sensitive projects. It also requires, though, accepting a little bit of risk sometimes. And it gets back to their recent comments about overclassification. There's been some overclassification, and it really hurts in recruiting. I'm gonna pile on a little bit. Okay, as an aerospace engineer, I know of no field more exciting than hypersonics. Well, obviously I work in that area, but if I thought there was any more exciting, I would do it. But it's flying higher, it's flying faster, it's pushing the edge of the envelope. It's what every aerospace engineer wants to do. So enticing students, young workforce into the field, I don't think it's difficult. It's then when we erect barriers that we start creating challenges.
Right, and I guess just to also add, certainly when you're dealing in the classified world, you can only do that work on site, right? So now you're competing with other maybe commercial companies that maybe have a flexible workforce or a remote workforce, and a lot of folks find that desirable in the post-COVID era. So you really need to have that flexibility, and also if there's, if they can do more work for you than in the unclassified world, they can do that anywhere, and then you can recruit from anywhere in the country and build it that way. But if everything is classified, then you're really limited to just those folks that are willing and committed enough to actually come back on site, more frequently than they're doing right now.
I'll add one other thing. the study talked about getting an ability to do more classified research with students, getting them engaged and excited about this work. And then they are ready to enter the workforce on the classified aspects of the programs, because there will be some, as soon as they come out of school. And I think that's a really good recommendation, but something we've got to figure out as a nation then is also, how do we incentivize those professors that are teaching those students and mentoring those students to do the classified work that they can't publish in traditional ways now? You know, the things that they're incentivized to do as a professor, a lot of those are taken away if you start getting into the classified work. There's certainly opportunities. There are classified journals, conferences, et cetera. But a lot of them, you know, they don't have the right incentive structure. And there are probably things that we as customers of that workforce could do to help them to incentivize the professors as well.
Exactly. By the way, if you'd permit me to put in a shameless plug for my new employer. So Purdue actually has something that they call the Civilian Training Corps, the Defense Civilian Training Corps. There's like 20 or so juniors, fall semester. It's one of 4 schools that's doing it, and actually getting getting students, you know, spun up on careers in national defense, and they're also producing graduate students who already have clearances by the time they finish up. And I think other universities are moving in the same direction as well.
Well, that's a great segue.
Sorry, shameless plug.
It's a great segue into my next question,
Okay.
which is cooperation between academia, industry, and government. So, for instance, what would be the incentives? How do you create incentives, and what are sort of maybe examples that could be done, for instance, to incentivize professors then to publish or to work on classified projects?
Yeah, well, fundamentally, I think it boils down to the research contracts. When they bring money into the university, that certainly helps. And then providing them the opportunities for quality publications that are classified, so that they can continue to build their record, but it's just not openly available. And then, you know, as Dr. Lewis has said, only classify what really needs to be classified. Take a good hard look at where are we overclassifying, what can we afford to not classify and allow for that.
Does that create, so if someone isn't tenure track, does that create a barrier to if they can't publish in the open literature? Is that something that needs to be addressed?
I'm not an expert in it, but that's what I hear. I don't know that any of us are experts there.
So it certainly can be. And look, you'll find there are faculty members who just don't want to do that sort of work, and fine, don't include them. I think the really good faculty members, though, want to work on things that are relevant and impactful, and they look for these opportunities. And, you know, I'll highlight, when we were doing this report, we, as Rebecca mentioned, we were aligned with the University of Maryland, shameless plug for my former employer, we aligned with the University of Maryland in their supply chain, and they were really eager to jump on board. And we're very sensitive in how they handle the information. So I think the good faculty members will gravitate to this. You're right, publication counts are important. In that, you need leadership at the top of the university saying, we need to consider other ways, other metrics of impact. And that's a difficult conversation, but I think we're moving in that direction.
There are audience questions? Were we going to that?
So while we're working on that, I'll put in a shameless plug for my current employer,
Please
the Air
do.
Force Research Lab. You know, and I think other service labs do the same, and there are other opportunities throughout the department. We have robust student internship programs as well. We have robust visiting faculty programs where we bring in students, we bring in faculty to do research in our facilities with our researchers. And I think that could also provide a opportunity to do more of the classified work in a way that is incentivized. It builds a good relationship with that university. It advances both the students and the professors.
Sharon, we've got a question from the online audience. It's an attendee who wants to remain anonymous, and she asks, is there an intent to include hypersonic programs on the DX-rated program listing to boost priority in the supply chain in light of other demands? Which is a bit technical, but I'll leave that with you.
I get it. Is anyone better versed than me want to translate that into?
So my
There's
understanding of it, and maybe you can help me, but the DX ratings, really what we're talking about is prioritizing orders, right? Particularly for a prime to the subs, so that you can reduce some of those lead times. There is a process for getting this DX rating. It says that you have a national security need, and that your order to that sub goes to the front of the line. They have to fulfill it before they can fulfill orders from anyone else. We get a lot of requests from Air Force program offices right now in my division of scientists and engineers doing research to help them to justify DX ratings because our program offices in the Air Force at least are struggling with what is that process, how do we do it, how do we build the record that we can justify that we deserve a DX rating for our program. What it tells me is it may not be a robust and well-defined program to increase DX ratings, but the program executive officers and all of those program managers are definitely getting the message that there is a way to help address some of these long lead issues, and they're trying to figure it out. And we're working right now with the Air Force Lifecycle Management Center in particular to try to develop a process within the Air Force so that they really know how to do it, and those program managers can do it. And we need our industrial partners to help us with it.
By the way, the issue of a DX rating is something that the team explored fairly extensively and looked at the pros and cons. One of the downside is it really is hitting the problem with a sledgehammer. And people are very reluctant to invoke a DX rating because it has lots of serious implications. So I don't know if we're there yet.
I don't believe that we are, but
Yeah.
I do see it. I see a lot more talk. I hear a lot more talk, and I see a lot more programs trying to build the records to get the ratings.
Yeah, from the industry standpoint, I've primarily been on the DO-rated programs, and every time you run into a supply chain issue, someone, be it our customer or prime customer, or even their customer in the room, will say, "Well, can you get it upgraded to a DX rating?" And it's usually a bridge too far, at least once we're at that point.
So it's not that useful is kind of what.
It's not an instant fix at the time. Right.
It's not, yeah,
Right.
exactly.
We've got another question from Mark Sellinger of Janes, and he asks, do China, and I think the panel have already touched on this, do China and Russia have the robust hypersonic supply chains that you're advocating for in the US? And if so, can we learn anything from them? And if not, how have they been able to advance their capabilities? I think you answered part of that with the IP question, but.
Unfortunately, I don't know much about their manufacturing capabilities out there. I would maybe suggest an educated guess is that we're not seeing them deployed in high numbers. Occasional news stories here or there in Ukraine, which would imply they probably don't have a large stock of them yet.
I would say I think the Russians have already shown in Ukraine that their weapons aren't really very good, which is more to say about Russian production than it is about the technology. By the way, the Chinese I think are a whole different story, and if there are lessons learned, I think there are several. One, the Chinese have taken this whole of country approach, government, industry, and of course there's a very close connection there. But even in academia. They have highlighted hypersonics as a national priority. It's one of their 16 national priorities. It has almost the same status as development of nuclear capabilities. And they have pressed the gas pedal down. I mean, they are moving as fast as could be. They're testing it but it's helping to build a workforce. They have an incredibly high success rate in their testing. And why is that? Well, because they do it often. They've gotten good at it. We're still lagging in that area. So yeah, I think there are a lot of lessons learned. That could be learned.
And we've got one from Mary D. Can you panelists, again, I think you've touched on this, can you panelists address the idea of the onerous government solicitation and procurement process, which takes time?
Well, speaking
Everyone
for
volunteer at once.
yeah, speaking speaking for industry, we always love when we hear that, hey, there's an RFP is going to drop, and it's going to drop on this date, and that date comes and goes, and then eventually it does drop, and then the due date is, less than a month or so, or something very difficult to put together a very robust and valid proposal. So that seems to be a very frequent occasion. So certainly, I think we're frustrated, but that's the world we live in. It's what we deal with, and we kind of gotten used to it, unfortunately.
So I'll say the same thing from the government side. I mean, I'm equally frustrated, right? I have a lot of issues with throughput in our contracting shops, so that we can get that RFP to you when we said we would get it to you. The demand on our very limited resource in contracting officers on the government side is very difficult to get through. Part of what I am doing as someone that's asking you for these proposals, right, is trying to really limit the number of things that I'm pushing through contracting, make them larger efforts that are more impactful, that are accelerating the key technologies that I need, so that I can limit how much they actually have to get through, and we can work through backlogs that we have with them. But fundamentally, I mean, I think we've got to take more risk in our contracting approaches. We've got to really understand the law and what we have to do versus what we do because we've always done it, or we've had some bad experience 20 years ago, or whatever. And we've got to be smart and efficient in the way we apply our processes, because it takes far too long for me as well, and it's just as frustrating on my side.
And there are some avenues for accelerated contract, like OTAs, for example, which for science and technology are being used more frequently, is what I've seen recently, which helps industry begin, start moving faster on the programs. Right.
And look, there are lots of really smart people who are tackling this issue, tackling this question. I'm going to put in another shameless plug. ETI is doing a study right now looking at lessons learned from Operation Warp Speed. So how do you move really quickly? And what the government has been able to do to move quickly when it needs to. Just doesn't always need to, or think it needs to.
More.
So we've got the report addressed it and Rebecca spoke to it, but a question from Lance Baxter: how should we be trying to take full advantage of our allies and partners' supply chains in this critical area while still protecting our IP and ensuring our national interests?
I don't know that industry has a good answer for that one.
I don't know if you want to keep seeing the same hands.
Go.
Yeah, I promise I won't dominate the next question. But look, what is one of our big advantages in the West? It's friends, partners, and allies. It's the incredibly rich S&T community that includes beyond our borders, and Hypersonics is the poster child for that. The department has built a beautiful relationship with critical allies. I think the congressman mentioned Australia, Norway. They're absolutely key to a number of the programs underway right now. I'll give you the example of Australia. So they've been key players in the hypersonics for decades. They've developed some of the basic technology. They arguably flew the first operational supersonic combustion ramjet. They have concepts for wind tunnel designs that have now propagated around the world. They also happen to have this incredible test facility at Woomera, which is in the Australian outback. And they have dedicated tremendous resources to supporting joint efforts, starting with a program called HiFire, which the Air Force put together in conjunction with Australia, and now transitioning to SciFire, which is one of the programs I'm personally most enthusiastic about, that leverages knowledge of air-breathing systems, but also with an Australian viewpoint for applications. So they're absolutely critical.
Great.
So we've got a question from Albert Lee of Overt Defence, and he asks, on the topic of budgeters policy, ARRW in particular was pitched as being capable of being developed faster for cheaper. When it comes to more money, would the panel's preference be for investing more in each programme to hopefully allow for better maturity, or to fund more programmes overall to rapidly separate what works from what doesn't?
So,
Go ahead.
well, I guess in my career, it's a kind of a personal frustration. And I think anybody that's worked on a program that was, well funded and had some success, and seems to be on a very good path, to all of a sudden hit some technical issues and then basically be shut down without having a chance to fix and recover and learn from that and move forward. So certainly a desire to stick with it. I think if we'd stuck with hypersonics 20 years ago, we wouldn't be in this situation right now, right? So just really staying the course. You have a mission. You're going to have some technical setbacks. You're going to learn from your failures and make improvements and be better, and you're going to get the system to work. So I've had the luxury or privilege to work on Arrow for the last 5 years. So that's a program near and dear to my heart prior to the HACM. So definitely rooting for it. Again, we learn by our failures, right? I had a senior engineer tell me 20 years ago that we learn more in a failure investigation than we learn from a successful test. If your product works, you never know really how close you were to that areas and what your ultimate capabilities were. So definitely need to be willing to take technical risks, learning, and don't shoot the messenger. Just pick up the pieces and get back on the horse and keep on going to get there.
Yeah, I completely agree. The question stated personal preference. So my personal preference, you keep investing in multiple programs right now. I think it's too early to down select. I think you learn from the failures. You also create a culture that is willing to take the chance to push the boundaries. That's going to be very important to creating the capability that we need. If we suddenly cut and run every time we have a test failure, you're not going to push it.
Right.
So my personal preference, we continue to invest in multiple options today.
So we've got another one. Can you elaborate on the role of additive manufacturing in refractories and what that will play in hypersonics?
Speaking for industry, obviously air-breathing engines rely very heavily on additive manufacturing, as well as conventional machining, welding processes. A lot of inspections go into it. So additive manufacturing in a secure environment is critical. So getting those small machine shops that maybe have not had a program with special requirements on the security or cybersecurity is challenging, right? You have to stand those places up, and they would not have invested in their own because, again, with no business case, they won't have that ability. So you have to basically take them along, train them, help them get up to speed of what they need to do to protect your information from an IP standpoint as well as a classification standpoint. So we've done that. We're now looking at teaming arrangements and setting up second, third sources so we don't have single point failures in the supply chain on the additive manufacturing side. We're starting to do a lot of that in-house as well. So again, in order to get these products at rate and at cost, there's a lot of investment that has to be done. Certainly there are multiple sources taking your part count down, whereas machine limitations might have held you to smaller envelopes. Bigger machines can print bigger parts, which means you need less parts, less cost. All those things that we're looking at and implementing for the air breathing systems going forward.
And I would add to it.
No, you go ahead.
Okay. From our perspective in Air Force manufacturing technology, it's additive when it makes sense to do additive. And so we are investing in additive where you need geometries you can't get from other methods. When the manufacturing rate is appropriate or the numbers make sense, the cost makes sense. But we're also investing in casting and developing casting methods for high temperature alloys that really don't want to cast in the geometries that you need because if we can crack that nut, we can achieve rate and cost reductions that we need. So it's additive where additive makes sense for the system, but it's a holistic approach to how are you going to accomplish rate and cost goals.
There's also, as far as the infrastructure for additive manufacturing, it's not a mature infrastructure yet. Industry and what I've seen, the government is still characterizing where it makes sense, the structures, where the additive manufactured parts can be applied. And this really ties back to the previous question about testing and such, because what we want to be able to do is produce parts, but test them fast to see, as well as assemblies, test them fast to see are they viable options for programs that are under development and programs of record to help augment and reduce cost in those programs. So it's all intertwined with the additive manufacturing as well as tying out to the quick turnaround for test results.
If I can, a tip of the hat to the person who asked the question, because the report actually does specifically address those issues, additive manufacturing, casting, and forging, and as they pointed out, absolutely critical.
Can I ask really what I think is going to be a hard question? So someone just asked what you do if you get more money. I was in a fairly important position in 2011. I see a lot of similarities. What happens if the budget is cut? How do you prioritize, and how do you get through the next dip?
Well, I guess that starts with me, right? And it's at that point you may have to make the hard decision to down select. You may have to make the decisions of where will that dollar have the most impact, and you push some of the risk out into EMD or later phases. None of those are good options.
They weren't in 2015 either.
I know they weren't.
So I would say I think you got to think. I think ultimately you got to think broadly in that when the budgets start dropping, you're going to be forced to compete hypersonics against other things. And I think you and I were both there when we had people saying, well, you know, the weapons we already own are less expensive than the new weapons we want to buy in the future. And that's really hard. That's really hard to fight against.
I asked the question for a specific reason. And if you remember, the Air Force, when the budgets came way down, tried to take a whole bunch of money out of their S&T budget. Mm-hmm. We got the secretary to tell us to put it back. Steve Walker and I did not let them put it back where they wanted to. We put it into the hypersonics, $360 million, 500 miles, Mach 6 in 5 years. And that really restarted this whole resurgence. But we made a choice that it was more important to invest in the future than it was to invest in what we had been doing. And that is something I'd like to see the department at least start to think about. I just had to throw that out there.
No, absolutely. Absolutely.
Suresh Acharya, University of Maryland. So first wanted to thank Rebecca and Mark and Arun, ETI team, for allowing us to be partners and collaborators in this effort. Thank you very much. I wanted to build on one of your questions, Sharon, around is it only the inconsistent demand, or is there something else we need to worry about? And I heard Jason start to bring up the single point of failure. So it's a comment followed by a question, if you will. So if we were to park the inconsistent demand that we all agree is a big issue and go over to the supply chain side, and we've talked about overlapping, competing, interconnected supply chains. And what has happened there over the 90s into the 2000s is with efficiency has come lean, and with lean, we have gotten to single points of failure in many, many places. And what concerns me is even if the demand signal starts to get clearer, will we have lingering issues because we have multiple points of failure, potential points of failure across the supply chains? So I just wanted to, ask the panelists what they're, and I know that the report discusses this as well.
Certainly, 100% agree. They're out there. Northrop Grumman tries to take a global approach in our supply chain management where we identify those sources. We make sure that it's broadly advertised throughout all of the corporation's departments, so we know our supply chain engages them to try to monitor their health and viability, and if there is a risk, then we work to mitigate that risk by either trying to stand up a second source or pursuing industrial-based sustainment type activities that might help them. So we try to take it more of a holistic approach to it. But there's no easy solution. You just have to make sure that they're healthy, and if there is a risk to your business, then you need to mitigate it and do what you can to get a backup plan in place.
And I think, Jason, industry has done a good job in identifying to us where we can invest those S&T dollars that we have to try to develop some secondary sources for really significant concern areas. And that has proven successful in a couple of cases, and it's something that we need to continue to do. And Mr. Schaefer, thank you. I was that Air Force guy that you told where to put that money before. But we did appreciate it, by the way. It was the people above us, so it's all good.
Other in-person questions, or we can go back to...
We've got another one from Steve Trimble of Aviation Week, who asks, there was some interest a few years ago in supporting continuous competition of scramjet-powered cruise missiles, so not down-selecting to a single company on HACM. Is that still a possibility, or would it be better to clarify the demand signal with a single supplier for that program?
Well, I don't think Northrop would like to recompete that right now. So I'll defer on that question.
Well,
You're
first,
up.
I'm up. Okay, first, hi, Steve. How are you doing? I'm following some previous comments. I think we still need to keep parallel efforts underway. And, there are some basic questions about scramjets that we still haven't fully answered. We can build them. We know they work. We know they operate. But if you ask me what's the best shape for an inlet of a scramjet, I'm not sure I can give you a definitive answer yet. There are different scramjet cycles and modifications in scramjets. So while it's something we can engineer, it's something we're still developing. I'm going to point out the Joint Hypersonic Transition Office was actually investing in different air-breathing engine systems. And there are companies that are looking even beyond that. So you've got companies that are looking at alternate propulsion systems, air-breathing systems that aren't scramjets, but other technology. I think at this point, it's still important we keep those going.
I'm going to take the moderator's prerogative to ask the final question. Considering how important from both the report and from our panelists the demand signal is, based on what we're seeing from the 2024 fiscal budget request, based on what you're seeing from the Pentagon, are you optimistic that after many years of sort of starts and stops, that the Pentagon is going to give that demand signal based on the leadership that's there now? I'm sure you don't maybe want to comment on someone, but I mean, in general, broadly speaking.
Just my personal opinion from what I've witnessed within industry, as well as the Hypersonic Industry Trade Show last week. The demand signal's there. I don't see it going away. There's a pressing need that the country has to deploy these hypersonic capabilities. So I guess I feel pretty confident that it's going to be around, not going anywhere.
What I have seen is there's been a very deliberate, aggressive effort by the government to fund not only the major programs, but also parallel research programs to ensure that if we do run into technological hurdles, that that's already in work. There's already Plan B in work. And so everything that I've seen from a funding perspective, I'm not seeing that would be reduced next year.
I'm a little reluctant to talk about my leadership, but I guess I'll twist the question a little bit and say more from the whole government perspective, the demand signal, right? And I am seeing the same as you are. Congress is putting more money in the budget specifically targeted at hypersonics. The Air Force, the Army, the Navy, we all see the need. OSD is well organized. So I don't see the demand signal going down in the near future. I actually think that we're starting to address the issue in the report, but we're not where we need to be yet either.
For me, the most reassuring element of all this, and I'm going to echo Chuck's comment, that it's not just the department, but it's the whole of government. And we heard opening remarks from Congressman Lamberton where he pointed out this is a bipartisan issue. And I've seen that firsthand. 10 years ago, I was involved, and others were involved in those discussions, explaining to leaders on the Hill and in the executive branch why this is important. I don't have to have those conversations anymore. They all get it. They all understand it. They're all behind it, and they've made significant resources available. So I am extraordinarily optimistic, and I'll point out that this time around we have a forcing function, because previously, back in 2011. We were kind of getting an inkling of what other people were doing. Now we know definitively. And we are in a race. And whether we choose to be in that race or not, we're in a race. So I think that's widely recognized, and I think that's going to keep this going.
Great. Thank you. With that, I want to thank our panelists and turn it over back to Arun.
So I want to thank our panelists for that great discussion, and Sharon, the folks in the audience, the folks online, the voice of Habiba for the great questions and the great discussion here. As we close, I want to thank the ETI team, especially Rebecca and her team, for putting together this great report. The whole NDIA staff who worked on this event. I want to thank our partners in the meetings team and in the marketing and communications team who helped us put together all of this. Thank you all. We couldn't have done it without your help. Thanks again to the audience for attending. Again, the link to the report is ndia.org/hypersonics, or you can find it through our various websites. I'd like to announce again the upcoming ETI sponsored and supported NDIA Emerging Technologies Conference this August in Washington, D.C., JW Marriott, August 28th to 30th. The conference is being held in close partnership with Undersecretary Hsu and Undersecretary LaPlante. It's going to focus on several of DoD's highest priority joint mission areas, as well as the broader set of emerging technologies that are going to shape the future of national security. It's going to be a great place for gathering between government, industry, and academia, where we can talk about the operational challenges, the business opportunities, and see some demonstrations of the new and emerging technologies that are going to be shaping this space. So there's information about that conference on our websites as well. I look forward to seeing you all there. Finally, please be on the lookout for our next report in the supply chain series we're working on right now. It's going to be on directed energy, as well as a series of reports on some of the technical areas that we talked about over the course of the day, software and microelectronics, as well as our drumbeat of webinars and podcasts. All of that is available for your consumption on the websites as well. Thank you again all for attending, and thanks everyone for such a great event. Thank you.